Right, let's talk about data centers. You might think they are just boring rooms full of humming computers, and, well, you'd be mostly right. But inside these rooms, something quite interesting is happening with the air. It's a bit like the weather, but on a much smaller scale. You get areas that are surprisingly warm, which we call hotspots. Then you have other areas that are a bit too chilly, and those are the cold spots. It's all to do with how the air, which is supposed to be cooling everything down, moves around the room, or more importantly, how it doesn't move around properly. Think of it like the engine bay of a car after a long spirited drive. If the cooling fan isn't doing its job properly, one part of the engine can get dangerously hot. It's the same principle in a data center, but with expensive electronics instead of pistons and valves. So why should we be in a tiz about a few hot spots? Well, it's because the computer equipment, servers, switches, other rack gear, are a bit like us. They have a preferred temperature for working conditions. If they get too hot, they start to get flustered and don't perform at their best. The delicate components inside them, processors, memory chips, are particularly sensitive. Heat is their mortal enemy. It's like leaving a chocolate bar in a car on a sunny day. It's not going to end well. When a server gets too hot, its internal fans spin up to full speed. They make a dreadful racket and use a surprising amount of electricity. If that fails, the server may auto-throttle to produce less heat. Worse, if temps keep climbing, the server will shut down to avoid damage. That's an unexpected outage, and it gives data center managers nightmares. Even without immediate shutdown, prolonged heat exposure shortens equipment life. It's like running a classic car near the red line. Seems fine for a while, but it causes unseen stress on every component. Now, you might think the simple solution to hotspots is just to turn the air conditioning up to 11, make the whole room Arctic. Problem solved, yes? No. That, I'm afraid, is a classic case of overcompensation, and it creates a whole new set of problems. The main issue with cold spots and overcooling in general is the staggering amount of energy it wastes. Cooling systems can account for nearly half of the building's electricity bill. When you create cold spots, you are essentially paying a fortune to chill air that isn't doing any useful work. This waste of energy is not just bad for the company's bank balance, it's also bad for the planet. Data centers are massive consumers of global electricity. Furthermore, this brute force cooling can sometimes make the hotspot problem even worse, creating strange air pressure dynamics that prevent cold air from reaching where it's most needed. Happily, there are some very practical and clever ways to sort out this temperature muddle. The first and most important idea is to manage the airflow. Many data centers now use a hot aisle/cold aisle layout. To make this even more effective, use containment systems. Add doors and a roof to create a sealed room for hot or cold air. Another overlooked fix: blanking panels. Fit them to block airflow shortcuts and prevent hot air from mixing with cold. Finally, match cooling output to actual heat produced. This is called right sizing. Modern units can vary speed and output in real time, avoiding massive energy waste. Be smart, not just powerful. Now, all these solutions are excellent, but they have a flaw. How do you actually know if they are working? You need data. This is where AKCP comes in. Clever little devices, the nervous system for your data center. AKCP offers sensors you can place around your data center. Their key tool, the cabinet analysis sensor, a strip with multiple temperature and humidity sensors. With AKCP, you know instantly where the problem is. Constantly monitoring, telling you exactly what's going on, turning guesswork into science. If a hotspot starts, the system can send an email or text alert. That gives you time to be proactive. You can investigate that overheating rack. Maybe a fan has failed or a door was left open. ASHRAE provides guidelines for server inlet temperature, recommended lower bound 18 degrees Celsius, upper bound 27 degrees Celsius, running at the high end 26 or 27 degrees Celsius. To save energy is tempting, but leaves very little safety margin. A small cooling failure can push you into the danger zone. AKCP gives precise real-time data so you can run efficiently and safely. The sensible way to manage a complex environment?